Hi, welcome to a product review by Robojax. My name is Ahmad Shamshiri, presenting this review from Canada. In this review, we are going to have a review for this DCP-305 30 volts 5 ampere regulated power supply with constant current and constant voltage. And this video, we are going to do the unboxing. After that, I'm going to test the current at 2 ampere and then 5 ampere. And then I will go with the lower current of up to 10 milliampere to see how much we can fit. Also, I'm going to open and show you inside, and also show you how to replace and remove the fuse. Let's get started with this. Product is from Yescom, exclusively sold on Amazon, either Amazon Canada, US, or in Europe or somewhere else. And the model is DCP-30V. And there is also, this is a 5 ampere, and there is also DCP-3010, which is 10 ampere. And if I get my hand on it, I'll have also a review of that as well. The product is sold on Amazon US for $50.95. And here are the specs. The input voltage depends on your region, either 110 or 220, 220 or 240 volts AC, and the output is from 0 to 30 volts. The maximum current that you can get is from 0 to 5 ampere. In both cases, the accuracy is on the screen 1%, and the ripple in terms of voltage is 10 millivolts, and for constant current is 20 milliampere. This is the package that I received it from Amazon. Now let's see what's in the box. I already opened it. We got this alligator clips with 4mm banana. And then AC power cable. Perhaps they will ship it at a different location with different plug based on the region. This is the power supply. Very solid belt. Let me explain the front. These two knobs are for constant voltage. This is to change the voltage, and this is for fine-tuning it. And this is for constant current, CC. And this is for fine-tuning when you set the output current. We have here 3 terminals. These two are negative or ground. They are short circuited, so these are only one terminal. This will be treated as one terminal, and this is a positive. We have the power push button here to turn on and off. Ventilation for air circulation here. At the back, we have AC power connector and a fan. Very sturdy, high quality handle. That's nice. Let's open it and see what is inside. And here is how it looks from inside. Very neat, clean design, wires, layout, components. And this is a close-up shot. As you can see, all these wiring and terminals have been very neatly connected. Everything has proper terminals, wires are secured. This portion shunt resistor for 5 ampere, and they use 2 of this. It will be soldered here for 10 ampere. Do not switch it, because still there is some other point that they have modified and changed, and also these components in terms of the regulator also will be changed to make it work for 10 ampere, but I just mentioned it. And the component that we see, these 3, this is for current, for A calibration, and this is for voltage calibration, and this is for impedance calibration within the circuit. So I do not suggest touching these. And here now I have connected this to my electronic load. You see it here. This is the electronic load DL3031, and these are the 2 terminals that from the circuit will be connected in here, and we will see the voltage here and the current. This is a USB screen, but I have actual exact item here. The positive from here is connected to this positive, and the negative is connected to here. And also I've put 2 extra wires to measure the voltage separately, that is connected to these sensors, so it's more accurate. But this is not necessary in measurement. We are reading 3.37. As you can see, that's the voltage that we have. And I'm setting the current now here. The current is set to 2 ampere. I'm turning it on from here. Now 2 ampere is being drawn. This also shows 2 ampere, 2.02, that is 2020 milliampere. This is 20, and we are reading here 2001 or 2000 milliampere. So it just shows 20 milliampere difference in 2 ampere. Keep that in mind, and you can see this light is on now. We are drawing 2 ampere from here, from this device, and at 3.3 volts. So let me increase this voltage from here, and you will also see the voltage here. So I'm comparing the reading from this device with a precise device that we have. Let's go to 5 volts. So 5.06, and here we are reading 5. That's 46 millivolts. That's 50 millivolts. 5 millivolts. That's 5 out of 1000. It's very small. Acceptable. And let me go for 12 volts. Pay attention. When it's 1 digit, we are reading 2 decimal point. When it becomes 2 digits, it is moved on this side, so we see only 100 millivolts. Now we are reading also 10 millivolts. This is 100, this is 10. So when it goes here now, we read only 100 millivolts. So 12 volts with 2 ampere, very accurate, and the load is also okay. And now if you pay attention here, the resistance of my electronic load is set automatically 6 times 2 is 12, so Ohm's law works. And also if you want to look at the power here, this is this multiplied by this will give you this power, 24 watt. Let's go to the next voltage, 15 volts, and many op amps used. So that's 15 volts at 2 ampere. If I want to increase the current here, that is the current, and I can move the cursor, this green, up to 2, and I increase it 3 ampere now. 3 times 15 is 45 watts. You're reading. Let me increase it to 4. That is 4 ampere we are reading here, and it shows now this is heat. The fan is running. I have to make sure this is getting cooled down. Now let's go 5. So 5 is the maximum that this can supply. at 12 volts. Right now it's 25 watts at 15 volts, sorry. So let me go to 24 volts. Now at 24 volts you see 121 watts with these decimal points. If I want to make it accurate, so now it's 120 watts. Let's go to 30 volts. Now we are at 30 volts, 150 watt total power of this. So you want to set this that this doesn't allow more than 1.5 ampere. Let's say at 12 volts. I will put it at 12. It's not now connected to my load. So it's at 12 volts, and this is a current knob. If before it was set to the maximum, let me put it here, and I can do the short circuit here. You see, now it's short circuit. So don't worry about that. So I've connected it, and it shows. So you can reduce the current. That's milliampere. We have set this to 446. If I increase this, it will increase. It goes to ampere, but it controls the voltage because the total power is calculated that way. Let's say you want it 1.2 amp. So 1.5, 1.4, and let me put it at exact. So now this is 1.2 ampere. I set it. If I remove this, now any load that you connect to this will not allow more than 1.2 ampere. Now if I set this to different current, it will not allow anything above 1.2 ampere. Turn it on. It allows only 1.2, and 1.2 is coming, and that's it. I can increase it from here, but the load is set to 5 amp. So maximum this will withdraw 5 amp from this. So I can change it, otherwise it's just, if I turn it off, you will see that the voltage is 12 volts. But if I go here, it reduces it to 1.2, and the voltage is dropped because this system, this needs 5 ampere. If I reduce that, if I reduce this 5 to 4, you will see 4, 3, 2. If I go 1, 2 ampere still above the value. Now I'm going 1. Now it is 1 ampere. 1 is okay because it's not above the value. We get 12 volts 1. So this controls it whatever current you want. Let's say you want to protect a device or something. This is how you set it. Put this as a short circuit, adjust the current, and remove the short circuit. How we can set for smaller, I want to see in terms of milliampere. Let's say you want to set, you see the current is supposed to be 0, now it gets 10. 10 is being consumed by my electronic load because the wire is connected. If I disconnect this wire here, you see if I disconnect it, it becomes 0. So my electronic load draws 10 milliampere regardless. So keep that in mind, that 10 that we have is on top of whatever we want. Let's say you want to make this 100 milliampere. Now it's this is 100 milliampere. I turned it on. So 100 milliampere is being drawn. As you can see here, it shows 110. And you know the reason is that my device draws 10 milliampere extra for the LED and extra stuff, just for sensing purpose. So this is very accurate. Now let's go for 200 milliampere. Now it's 200 and it shows 209. So 9 milliampere extra. This is 200. Now I'm going 300 milliampere, 311. So 400, it shows 415. So you see 15 milliampere. So 5 milliampere extra, because 10 is by the electronic load. Now let's go lower, see at what current we can measure. So 10. Now I put this at 10. As you can see, it shows 11. Here it shows 20, because 10 plus 10 is 20. So the current is also amazing, unbelievable. To remove the fuse, you get a flat screwdriver at this point. Just insert it and remove it like that. Thank you for watching. This was the review of this DC305D power supply. As you saw that my test shown that this is very accurate in terms of voltage display and current limitation and display, constant current, constant voltage, up to 5 ampere and even 10 milliampere. You can control the amount of current as well. So I have no affiliation with them. I just purchased it for a family member and I did the test. The decision is yours, and I definitely recommend this in terms of quality of setting the voltage and current. However, one thing that I don't know is how long this will last. What is the quality in terms of durability? The time will say. Until then, this was my test result. Make sure to thumb up if you learned something and found this useful, as this will help my video in the search algorithm of YouTube. One thing that I don't know is how long this will last. What is the quality in terms of durability? The time will say. Until then, this was my test result. Make sure to thumb up if you learned something and found this useful, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, you may subscribe now.